Welcome to section 5.2, composition of functions. So in this section we're going to be expanding and formalizing a couple of ideas that we've seen already. The first portion of this section, if you refer to the notes, the first page in the notes for this section 5.2, introduce some definitions. So we're going to be looking at new notation. So if we see something like f plus g of x, here we're saying the function's name is f plus g, and it is a function of the variable x. Now, how we're going to find this function or evaluate this function at values is using the definitions in the notes. So f plus g of x means f of x plus g of x. We sometimes drop the x part and we just call this f plus g. But these are the two notations that are going to be the most useful for us in the section. And the notation for f minus g of x means we're going to take the function f of x and subtract the function g of x. And for f times g of x, we're looking at f of x times g of x, where we'll replace f and g with whatever their definitions are. And f over g of x would be something like f of x over g of x. Alright? Now all of these definitions, the first three at least, work for all x in the domains of f and g. In other words, we can't plug something into f plus g of x unless we're allowed to plug it into f of x and into g of x. Now this last one is a little bit slippery. This is defined, this new function f over g of x is defined for all x in the domain of f and of g, except where g of x equals 0. In other words, we can't plug in an x value that would make the denominator of this function equal to 0. And we'll see in a few minutes what we mean by that. Alright, so here in our first example, we're given two functions. F of x is the function 2x minus 1, and g of x equals negative x plus 2. So if we would like to figure out what this new function f plus g of x is, all we need to do is remember the definition. This is the same as saying f of x plus g of x. And because we know what f of x and g of x are, we can plug those in. So 2x minus 1 plus negative x plus 2. There are two functions we're plugging in. And we can usually simplify these a little bit. 2x minus x would give us x, and negative 1 plus 2 would give us plus 1. So that's our function. Now we'll come back to that idea because finding the function is nice, but what does this function actually do? Well, the function f plus g of x should have the effect, when we plug in an x value, of giving us the result of the action where we plug that x value into f and g and add the result. Alright, so we'll come back to that idea. For right now, let's look at the f minus g, the difference. So that's f of x minus g of x. And again, we know f of x is 2x minus 1. And we're subtracting negative x plus 2. Alright, now the subtraction case introduces a little bit of a hiccup. Here we're subtracting one function from another, so we need to distribute that negative. So we have 2x minus 1 minus negative x, so plus x, minus 2. So distributing both of those, and we'll simplify that to 3x minus 3. Alright. Now here in part C we see something very similar, but this time we are taking the difference in the other direction. We're saying g minus f. So we'll take the function g of x and subtract the function f of x from it. So we're going to take negative x plus 2 and subtract 2x minus 1, having the effect of distributing that negative into the other function, f this time, so negative x plus 2 minus 2x plus 1, and our final result, if we simplify and combine like terms, negative x and negative 2x gives us negative 3x, and 2 plus 1 gives us plus 3. So the order that you perform the subtraction does matter. Alright, now for something a little bit more interesting, f times g of x. That means we're going to take f of x, we'll do that one first, f of x, and multiply it by g of x. So we're taking the 2x minus 1, and we're multiplying it by negative x plus 2. And so what do we need to do at this point? Well, both of these functions are binomial in form, so we're going to need to FOIL these out. Now you could leave it like this, but this might not be the simplest way of leaving your function. So we'll simplify this completely. If I distribute my first terms, will give us negative 2x squared. 2x times 2 would give me 4x. Negative 1 and negative x give us a plus x. And negative 1 times 2 gives us a negative 2. So our final answer, what is this function? It is the quadratic negative 2x squared plus 5x minus 2. Alright, now what this function does, f times g, this has the effect of plugging the input into the two functions f and g and then multiplying the result. So we could perform that action, we could plug in an x value into both f and g and multiply the result, or we could plug that x value into this function that we came up with. It may be simpler to do it one way or the other. We'll see an example of that later on. Alright, now our quotients, here f of x over g of x, we would put the 2x minus 1 over negative x plus 2. Alright, now there are no common factors in the numerator and denominator. I can't cancel the 2's, I can't cancel the x's because they're terms, not factors. So the only thing left to say is, what can't x be? What is the restriction? Well, x could be anything that we're allowed to plug into f or g. And remember, those are both lines, those are both linear, and there are no issues with any x values, so that would be all real numbers in both cases. But this new function is rational. So we want to watch out for dividing by 0. And we can do that by saying that x can't be 2. Right? If x were 2, then my denominator would be negative 2 plus 2, or 0. So this is our actual function. We would want to say the definition of the formula for the function and the restriction on the inputs. Right, now if we went the other way, if we said g of x over f of x, that's what we're saying when we say g over f of x. We're asking for the function which puts g over f. Alright, now we know g of x is negative x plus 2, and f is 2x minus 1. Alright, now what's the restriction here? Well, if we look at the denominator, if 2x minus 1 equals 0, that's because 2x equals 1, that's because x equals a half. So that's what we don't want to accomplish. That's what we don't want to have happen. So x cannot be 1/2. And that is the name of that function. So that's how we would find our functions, just using those definitions and taking the functions that were given and putting it all together. Now, these definitions work for the general case where we're given a formula, but they also work for the specific case where we know what x is. So let me look at another example real quickly.